Section 11.3 is about the last type of conic we're going to cover, called hyperbola. Hyperbola kind of look like two parabolas that are pointing away from each other. And there are two types of hyperbola that we're going to deal with, and here's the first one. Let's talk about the hyperbola that point away from each other but pass through the x-axis. Now, because the hyperbola look like they're parabolas, we say they have vertices, and they have two vertices. And the vertices here are on the x-axis. Just like the parabolas we discussed, they're going to have these focal points inside, the foci. But instead of using P as the distance from the vertex to the focus like we did with the parabola, we're going to say that this distance here is C. The hyperbola also have asymptotes. Remember, an asymptote was a line that a graph gets closer and closer to but never touches. So there are these lines that the hyperbola actually get closer and closer to but never touch. And we'll talk about what the equations of these asymptotes are in a moment. The equation of hyperbola that open to the left and right, whose vertices are on the x-axis, is x squared over a squared minus y squared over b squared equals 1. I want you to notice the only difference between this equation and the equation of an ellipse is that this one has a minus sign in it, whereas the ellipse had a plus sign. We're going to say that the vertices are a units away from the center. So if you know what a is, well, you know what a squared is, you can take the square root of it, and you know how far to the left and right of center to put your vertices. We'll talk about B here in a second. The asymptotes, they have the equation, let me go back and actually use green. They have the equation y equals plus or minus b over ax, where b and a are gotten from the equation. Now let's talk about b. B, the square root of b squared, is going to tell you how far above and below the center you are. Well, those don't lie on the graph. However, what they are going to do is they're going to make this box that goes through the center, the middle portion between the two hyperbola. So another way of talking about the asymptotes is that the asymptotes are actually the diagonals of this box. Now, my picture doesn't do it any justice. If you look at the picture in the book, it's much better. The asymptotes should actually be the diagonals of that box. So the vertices here are going to be at plus or minus a comma 0. We're going to call the distance between the vertices the transverse axis. That's the distance between the vertices, and that distance is 2a. Because if it's a units from the center to one vertex and a units from the center to the other, together they make 2a. The foci, we're going to say that they are at plus or minus c comma 0, where c squared is equal to a squared plus b squared. Now again, notice that this formula for determining c is a little bit different from the one we use for ellipses. I am not asking you to memorize these formulas because they can often get very confusing. So you, again, need to just be able to use them if I give them to you on a test. All right, now we have to talk about the hyperbola that opens up or down. And you're going to know by just looking at the equation which one it's going to be. Here's a picture of hyperbola that opens up and down. And the equation for this particular hyperbola is y squared over a squared minus x squared over b squared equals 1. So here's the deal. If your hyperbola equation starts with x squared, it's going to open to the left and right. If it starts with y squared, it's going to open up or down. So we still say that the vertices are a units away from the center. The transverse axis is still 2a units. I'll call that TA this time. This time the transverse axis is a vertical line. In this previous example, the transverse axis was horizontal. I'll do B first. Okay, so B tells you how many units to go to the left and right of the center. And then you can make this little box. The asymptotes are the diagonals of that box. The asymptotes for this one have the equation y equals plus or minus a over bx. Notice it's the reverse of the previous example. And the foci, which are inside the little parabolas of the hyperbola, which are still c units away from the vertex, are going to this time be at 0, plus or minus c. I should have said the vertices. This time we're at 0, plus or minus a. And then c squared is equal to a squared plus b squared. Let's do a hyperbola example with a transverse axis. A hyperbola has the equation 9x squared minus 16y squared is equal to 144. Find the vertices, foci, and asymptotes and sketch a graph. To find the vertices, foci, and asymptotes, we kind of want this equation to look like the equation that I gave you in the general cases. And that means I want the equation to equal 1, and right now it doesn't. So what am I going to do to make it equal 1? I'm going to divide everything. Oops, sorry about that. Clear that. Go back a page. Sorry. I'm going to divide everything by 144. And I did something similar to this with the ellipses. So first we're going to start by simplifying. We're going to reduce those fractions. So 9 over 144 is 1 over 16. So I'm going to start with x squared over 16 minus 16 over 144 reduces to 1 over 9. Y squared over 9 equals 1. Now that's much easier to deal with. So I know that this is hyperbola that opens to the left and to the right. That means that I want to use that set of equations to find my vertices, foci, and asymptotes. So the vertices, if it opens to the left and right, is at plus or minus a comma 0. A, in this case, since this is a squared, must be 4, so it's at plus or minus 4 comma 0. The foci, well, you know what, I'll skip. Let me do the asymptotes first. The asymptotes are at y equals plus or minus b over ax. That's going to be plus or minus 3 over 4x. Now I'm going to go back and I'm going to find the foci. The foci are at plus or minus c comma 0, but the problem is I have to find out what c is. I'm going to use c squared is equal to a squared plus b squared. And I'm going to double check and make sure that's the right equation, which it is. So c squared is equal to 16 plus 9, which is 25, which means that c must be 5. So the foci must be at plus or minus 5 comma 0. So now if I want to go back and draw a quick sketch, let me get rid of this. Oops. The vertices are at 1, 2, 3, 4, and 1, 2, 3, negative 4. And let's see if well, I'm going to draw it like this. The b is 9, so, sorry, b squared is 9, so b is 3. So I'm going to put a point 3 units above and 3 units below. And I'm going to draw this box here. The reason I'm going to draw this box is because the diagonals are then my asymptotes. That's my plus or minus 3 over 4. So now to draw the hyperbola, it's going to look like that. And it makes a little bit nicer looking parabola than it is if I just tried to go and graph the asymptotes freehand. I think it's nicer to make the box and make the diagonals of the box as your asymptotes. Now let's talk about a hyperbola with a vertical transverse axis as opposed to the previous problem that had a horizontal transverse axis. Find the vertices, foci, and asymptotes of the hyperbola and sketch its graph. And the hyperbola is x squared minus 9y squared plus 9 equals 0. Alright, this is in general form. We need to put it in standard form, or the standard form that we need. So I want you to watch this. I'm going to subtract 9. Because now I've got x squared and y squared together on one side of the equation. But I need this to be an equation that's equal to 1. So I'm going to divide everything by negative 9. What's going to end up happening is this term is going to be negative, and this term is going to be positive. I always want the positive term first, so I'm going to write this as y squared minus x squared over 9 equals 1, and this is going to be my hyperbola. Remember, this is over 1. So what ended up happening is I ended up switching the terms, the x and y squared. Because of that, y squared comes first. And if it comes first, that means this is hyperbola that opens up and down. So that's the set of definitions that I need to work with. Once you get to the equation, the rest of the stuff is simple because it's really just plugging into some expressions. So let's start with the vertices. If the parabola opens up and down, the vertices are at 0, comma, plus or minus a. Well, a in this case is 1 because this is a squared. So they're at 0 plus or comma, plus or minus 1. The asymptotes in this particular case are at y equals plus or minus a over bx. So they're plus or minus 1/3 x. Now to find the foci, which are at 0 plus or minus c, I need to find out what c is. Using c squared is equal to a squared plus b squared. So c squared is equal to 1 plus 9, which is 10. So c is the square root of 10. So the foci are at 0 plus or minus the square root of 10. Now I can go and draw kind of a quick sketch of this. So I'm going to get rid of this. My y squared over 1 minus x squared over 9 equals 1. So let's draw a little sketch here. A is 1, so I'm going to go 1 unit above and below the center, which is at 0, 0. Those are my vertices. B in this case was 3. That's what's going to help me draw my little box, so I know what my asymptotes are. They're the diagonals of this box. Again, I don't do quite justice, but you get the impression. And then the hyperbola will open like this. They'll be really wide. And there's a general sketch of the the hyperbola, x squared minus 9y squared plus 9 equals 0. Now I want to find the equation of a hyperbola from its vertices and foci. So if I tell you the vertices of a hyperbola are at plus or minus 3, 0, and the foci are plus or minus 4, 0, Let's find the equation and sketch its graph. Now I'm going to draw a little sketch over here. I know that the vertices are at 3 and negative 3, 0. And I know the foci are at 4 and negative 4, 0. So I know that the hyperbola is going to look like this, just to start with. Knowing that tells me that I'm going to write an equation that says x squared over a squared plus y squared over b squared equals 1. So let's start with the fact that the vertices are a units away from the center. So if a is 3, then a squared is 9. So I already know this is 9. The next thing I need to find is b, and right now I don't know what b is. But I know what c is. And I know that c squared is equal to a squared plus b squared, so I know that 16 must equal 9 plus b squared. And I know that b squared must be 7. I don't even need to take the square root of that, because I really want to plug in b squared into the equation. So now I'm going to come back up here to the equation, and I'm going to replace the b squared with 7. And guess what? There's the equation. There's the sketch of the graph. And that's really all you need. Now let's find the equation of a hyperbola from its vertices and asymptotes. Find the equation and the foci of the hyperbola with vertices at 0, plus or minus 2, and asymptotes y equals plus or minus 2x. Sketch the graph. Let me start with a little quick sketch. If the vertices are at 0, 2, and 0, negative 2, that means that the hyperbola must open up or down. So at least I kind of know how this starts. I don't know how wide they are, that depends on the asymptotes, but at least this gives you a general idea. So I know the equation is going to be y squared over a squared plus, minus x squared over b squared equals 1. And since a is the distance from the center to a vertex, that's 2, so a squared is 4. So now I can get rid of this and replace it with 4. So I know part of the answer. Well, now what I need to figure out is I need to find out what b is. But they didn't give me c. They asked me to find the foci, so I have to find c later on. But they did give me the asymptote, and I know that the asymptotes for parabola or hyperbola that open up and down are plus or minus a over bx. Well, if this hyperbola has the equation for an asymptote plus or minus 2x, that must mean that a over b equals 2. Well, I already know what a is. A was 2. So 2 over b equals 2. So b must equal 1. Alright, so now I can come back over here and replace b squared with 1. So the equation of the hyperbola is y squared over 4 minus x squared over 1 equals 1. Now I need to find out what the foci are, and in order to do that I need to find c. So c squared is equal to a squared plus b squared. A squared plus b squared is 5, so c must be the square root of 5. So the foci must be at 0, plus or minus the square root of 5. And that is hyperbola in a nutshell.